Welcome, everyone. Thank you so much for joining us today. This is Penn Engineering Online Admissions webinar, and today we are going to be focusing on our online Masters of Science in Engineering and Data Science program. This is our newest online program, and we are excited to discuss the details with you today. My name is Jackie Panto. I am the Admissions Recruitment Manager for Penn Engineering Online, and I work with the rest of the admissions team helping potential students just like you to understand our programs and to also navigate through the admissions process and the application elements, all of which we're going to go through today. I am thrilled to let you know that also joining me today is our Associate Dean, and it's Associate Dean Boon Thau, and he's here today, and he's going to take a deep dive into the MSE-DS program and talk about all of the curriculum and the details and the Penn community and everything else that goes along with it. The exciting thing is that not only is Dean Liu, not only does he handle all of our graduate programs at Penn Engineering, he also teaches in Penn Engineering Online in our program. So you as a potential student, if accepted, may have the opportunity to take his course and to get to work with him even closer and to get to know him as a professor. So that's really exciting and a great opportunity for our students. So before we begin, I just want to go over some webinar housekeeping items with you. There's always a few things that I like to go through just to kind of keep everybody up to speed. So first of all, we are being recorded. The webinar is being recorded, and you'll be able to watch that again and again. So no need to frantically take notes and no need to worry about if you missed something. You certainly can go back and rewatch the webinar. In addition, all of our past webinars have been recorded, so they're a great resource for you. I know a lot of people have questions, and going through our past webinars can answer a lot of those questions. We actually did a webinar series back at the end of January where every day we had current students doing a webinar and joining us, and they talked about their journey and their experiences at Penn Engineering Online. So it's a great opportunity if you are curious and want to know what it's like to be a student. I would highly recommend that you go back and watch those recordings. I think you'll really get a better experience or a better feeling of what it's like to be a student here. So past recorded webinars are an excellent resource for you. If you have questions today during the webinar, we want you to use the Q&A function in Zoom. That's on the Zoom toolbar. Please type your questions in that area. And then we do have members of our admissions team behind the scenes. They'll be answering those questions, and they'll also be feeding some of those questions to us at the end of the webinar. We're going to save about 20 or 30 minutes at the end of the webinar for Q&A. So all questions need to be typed in the Q&A. Some will be answered behind the scenes, and then others will be answered at the end of the webinar. So I think I've covered just about everything to get us started. So I am going to turn the webinar over to you, Professor Liu. It's all yours. Thanks again for being with us today.
Thank you, Jackie. It's first of all, it's a great pleasure to see everyone, and thank you for taking important part of your day to hear us talk about MSE-DS Online. As all of you know, data science is now so fundamental to everything we do today. I'm sure all of you have used ChatGPT, right? And it's an amazing tool that provides you artificial intelligence and machine learning capabilities and to answer different kinds of questions. And this is a field that's rapidly changing, and data science is central to everything that we do. And it is not just limited to a chatbot, right? So if you consider many aspects of medical advances, material advances today, to even how we tackle problems of precision agriculture and climate change, at the core of that is really to be able to collect data at scale, to process them in real time and make meaningful observations based on them. So our MSE-DS program is based on a long history of successful work done in the area of data science at the University of Pennsylvania. Our database research group is one of the most advanced and prolific in terms of research in the country and in fact around the world as well. And a couple of years ago, we started the Data Science on Campus program, which has now developed into one of the most successful master's program within the whole university. And we are really excited to be able to build on that success to now launch the online version of the Data Science Master's program. Now, underlying the importance of this area, some of you may also be aware that our university has announced large investments in the areas of data science meet healthcare in the new data science building, the Amy Gutman Hall, which is named after our previous president. And that is, and all of these efforts really showcase the importance of data science. So with that said, Jackie, can you move on to the next slide? So why Penn, right? So I'm sure as you decide upon the possibility of studying data science, you will come across many options from different universities. And here are just a few reasons on why our program is unique. So first of all, you'll be studying from world-renowned faculty members. We pride ourselves in our online programs to leverage the same faculty members who teach the classes on campus. Many of the faculty, including myself, we are research active faculty. We regularly teach to on-campus students. And so the very same faculty who are developing and delivering our world-class education will also be the ones teaching to you online. We don't take shortcuts and hire adjuncts and part-timers. And so a lot of the work, the heavy lifting, is done by standing faculty. And the second one is that a lot of the material is developed at a very high quality in an asynchronous manner. So I understand that many of you probably have jobs, you may have other commitments in your life, but the great part of our program is that we spend a lot of energy and efforts, invest in high quality video recordings that you could watch at your own time and convenience. But at the same time, we combine that with synchronous sessions where you could meet faculty members like myself, where you can ask questions and go through more difficult problem sets together with us in real time over Zoom. And consequently, this is a really flexible curriculum that allows you to attend classes full-time or part-time, right? So if you decide, hey, actually, I would like to maybe do this full-time, then you could do it from the leisure of wherever you are without having to relocate to Philadelphia and take 3 classes every semester and try to finish the program quickly. Or you may decide you're in a job or in a family situation where it's more convenient for you to take 1 class per semester, and both are equally good options. The other thing I want to mention also is that in a lot of data science programs that you would come across online, they could be very heavy on business analytics. But one of the differences in our program is that we're really training you to be engineers, right? This is a MSE-DS program within the School of Engineering and Applied Science. So to give you an analogy, you could, for example, take classes that teaches you how to use SQL queries or use Excel spreadsheets or write simple data manipulating programs in Python. Certainly, there are a lot of programs that would offer you that kind of training. However, if you think about how ChatGPT works, right? It uses deep learning, neural networks, and it's not just a triumph of machine learning and data science. It's a triumph of distributed systems too, right? Underlying a tool like ChatGPT is the ability to ingest and crunch through tons of data at high throughput in large numbers of computers running high performance GPUs and so on, right? And if you come to a program like Penn, then we would be able to teach you techniques that not only allow you to work with data, but more importantly, to build data infrastructures, right? Software that can power next generation cloud data center infrastructures that allow you to make all these new data science innovations possible. Next slide. Earlier I mentioned that a lot of the classes are taught by our faculty members who are research active. And I'd like to walk through a number of these faculty members to give you an idea of who are the faculty in the program. And let me just name a few. I could spend a whole day talking about it. So our department chair, Professor Zach Ives, he is both an ACM fellow and a lean back winner, and he teaches one of the core classes in MSE-DS. ACM stands for the Association of Computer Machinery. It's the organization that gives out these fellows, which are to the top 1% of computer scientists in the world. We have very few of these ACM fellows in our school, and it's really wonderful that Professor Ives is able to teach for this program. Lean back is the award given at the university level, and there's very few such awards every year to distinguish faculty members who excel at teaching. So on this slide alone, you can see 3 Lean Back Award winners: Professor Zach Ives, there's Professor Susan Davidson, and Professor Andreas Heberlein. And all 3 of them are teaching important classes for the program. And also on this list, you can also come across faculty that are outside of computer science as well. So there is Professor Victor Preciado, Professor Hamed Hassani, and Professor Pratik Chowdhury. They're actually faculty members in our electrical and systems engineering. And interestingly, data science has strong intersection with systems engineering, which is an adjacent field. And one of the things we recognize is for you to become a top data scientist, you have to be both strong in software engineering and strong in statistics. And we're really happy to be able to bring on board some of our colleagues in the electrical and systems engineering department. And several of them have also joined appointment in computer and information science. Now, on just the last 2 slides alone, you notice, I think by my count, there were at least 3 or 4 ACM fellows, right? This is, I don't know any other master's program you would find on this planet taught in an online fashion where you have 4 ACM fellows teaching to you day in, day out. This is truly an amazing opportunity that I think is hard for you to find elsewhere. All right, so hopefully by now, all of you have already decided you're going to apply to MSE-DS, and very much looking forward to see your application. So this slide tells you who qualifies. Now, one of the things about this program is we want to make it accessible by drawing upon a large spectrum of learners. As a result, the curriculum is flexible enough to accommodate students that come in with different backgrounds. We do require that you have some ability to already be able to program. And so let me walk you through 3 possible categories of students. And none of them, I would say, are like superior to the other group. So it's really providing different pathways for you to end up to the same destination. The first is if you have already come in with an undergraduate degree in computer science, right? So maybe in your undergrad degree, you had a taste of machine learning, took 1 or 2 classes, and now you would like to deep dive into topics related to machine learning, deep learning, and so on. Now, you could take classes in MSE-DS that would really be considered a computer science master's degree with a data science or machine learning concentration, right? So in fact, the choice of classes that you take would closely mirror that of a computer science master's student. The second category is, suppose you had an undergrad degree that's not computer science, but you have done some computer science classes. This could be part of a CS minor, which is offered in many places, or maybe you were just interested in coding and you took 1 or 2 introductory classes, you got excited, and you decided to take 1 or 2 more. And so as a result, you have some basic training that allow you to continue on in the MSE-DS program. So we don't like to specifically restrict the set of computer science classes, but broadly speaking, and you should view this list as informational only, right? And there could certainly be other classes. You could have done an introductory programming class, a class on discrete mathematics, a class that covers computer systems or hardware. By that, I mean a class that teaches you how, say, assembly works, how binary, hexadecimal, and so on. A class on data structures where you've heard about terms like linked lists, binary search trees, heaps, stack, hash tables, and so on. But if you have not taken any of these classes, please don't be discouraged. We know that in many different programs, many different universities, you have similar or maybe adjacent classes with different names. So as long as you have done 4 computer science foundational classes, that would allow you to qualify for the MSE-DS program. Now, with these 4 classes, we may require you to spend a bit of time taking 1 or 2 additional classes to beef up your background, but they would count towards the 10 credits needed for graduation. Last but not least, and I've certainly come across learners in this category, where some of you may have graduated with a degree that's outside of computer science, maybe even in biology or some STEM areas, but you have worked in the industry for a while, and you have picked up the knowledge in software engineering, either working as a data scientist, software engineer, or any sort of quantitative coding experiences. Now, if you feel like you fall in this category, you should certainly also consider applying to our program. Next slide. So here is a bird's eye view of the MSE-DS curriculum. And broadly speaking, there are 3 categories of classes. The first is what we call the core classes. They are the foundational class that we feel every data science student should learn. The first class, CIS 5450, is taught by Professor Zach Ives. It's a very popular class on campus where annually we attract hundreds of students from all across the spectrum. It's a 3-in-1 class. It teaches you the basics of databases, distributed systems, and machine learning. And it gives you a teaser into every different area. So this is a great class to start off with because at the end, you get a very wide spectrum of what data science is about. CIS 5500 is a class on databases and information systems. It's taught by Professor Susan Davidson, whom I mentioned earlier. And this is the class that goes into the internals of how database systems work. And at the end, students work in teams to build a really cool database application. ESE 5410 is a machine learning class. And we also require you to have some basic knowledge in mathematics and statistics. And you have 2 options. There is a class which is taught by Professor Hamed Hassani, which is more on the statistics knowledge behind data science. And we also have a linear algebra class, which covers the fundamental underpinnings of machine learning algorithms. Now, together with these core classes, we also have a number of technical electives. And one thing I will stress is that this slide here is not a static slide, right? If I were to show these slides in a year's time, we're going to have more and more classes added over time. But the tech electives is where you are kind of based on your interests, decide to deep dive into different areas. For example, if you're really interested in how self-driving cars work, then you want to be able to take classes in artificial intelligence and also computer vision, which is about recognizing images and so on. If you are very interested to learn about how ChatGPT works, for example, then classes like the deep learning class and natural language processing are the classes you should focus on. If you're interested in the infrastructure behind big data and cloud platforms that powers any data science infrastructure today, then classes like CIS 5550 and the computer security classes would be of interest to you. And the best part of this program is you can choose, right? You can decide to go in depth in a certain area, or you can decide to go in breadth, right? And cover kind of both the mathematics, the statistics side of things, the machine learning side of things, and also the infrastructure side. Last but not least, there's a number of open electives, and many of these classes are interesting in their own right. For example, I'm sure many of you are curious about how your iPhone works with 5G, 6G, LTE technologies, right? It's hard for us today to do anything without our phones. And we have a class just for that, right? It teaches you how wireless communication, mobile computing works. Um, and if you come in with maybe a little bit less background, we have some classes that allow you to fill in some knowledge gaps. CIT 5950 is a class that teaches you C programming, how operating systems work, like how your Linux and Windows operating system are designed and built. And also algorithms class teaches you about all the computational techniques used in computer science. So should you come in without a computer science undergrad degree, some of these classes here would help you fill in the gaps, and you would still have enough course credits for you to do a deep dive in all the other exciting classes. Next slide. Cool. So with this, I'm going to hand it off to Jackie, and I'll be around, and we'll be happy to take questions later on.
Great. Thanks so much, Associate Dean Liu. That was wonderful. I am going to pick it up here and talk a little bit about the course experience. So as Professor Liu mentioned, all of our courses are pre-recorded lectures. There's no required real-time session, so there's no worry about having to log in at a certain time. All of our lectures have been professionally recorded. Everybody comes into our studio here on campus, and they're just, everything's done professionally, and it's done keeping the end user in mind, the online learner in mind. So that's really important to us. There are going to be things in the class such as ongoing discussion forums. So it's really important for us here at Penn to make sure that our online community is vibrant and that our online community is collaborative. So we do make sure that our courses do have that open discussion board, discussion forums as well. So you'll be conversing with other students, with TAs, with professors. Our TAs and our professors all have office hours as well. So you can certainly get involved and ask your questions that way. Because we say that there's lots of flexibility, which there is, I want to just make sure you understand that it is within somewhat of a structured environment, though. All of our courses, there are syllabus, there's syllabi, there are dates that you have to abide by. There'll be coursework that is released and problems that have to be due by a certain date, or quizzes that are on within a certain time period. So you do live between weekly and bi-weekly deadlines, but you can do your course when it's best for you, when it's convenient for you during that chunk of time. So you will work with certain deadlines in the program, but again, you have the ability to work it into your schedule. You have the ability to work with groups based on what everyone's schedule looks like. So there is a lot of flexibility within the programs, but of course, there are going to be deadlines, and there will be structure to our online programs as well. I heard one of our professors at a previous webinar call our teaching assistants, our TAs, as he called them. There's just so many TAs. It's like an army of TAs out there, and that really is true. We have wonderful TAs that will help our students. I believe the ratio is something like 1 TA to 20 to 22 students. So there are always plenty of resources, plenty of people out there to help you. And if you listen to some of our past webinars with our current students, one of the things that really is really something that almost all of them talk about is how current students are always willing to help other students. And there's really just a lot of collaboration, and students want to help other students. Our TAs are, like I said, readily available to answer questions within 24 hours. And again, our faculty are always available through office hours as well. So we really make our courses as vibrant and as collaborative as possible. We want our students to be involved. Next, I want to talk a little bit more about that. And I think one of the best things, and really this is a big point of difference as well, is the vibrant community that we have, the robust community that we have. And it really, when I talk to students, it really kind of blows me away at that is what comes through time and time again and what they talk about. There's several ways that this happens. One, there are with within the Penn Engineering Online community, there are student associations and student groups. This seems right now is revolved around our first program, which is our MCIT program, but this is something that we're looking to do also in the MSE-DS Online program. Again, the MSE-DS Online program is new. Actually, Spring 23 is our first cohort. So these are all the things that we would like to model in terms of student organizations, student groups, student-run associations, because that's a great way to get involved. Again, I mentioned our TAs, our army of TAs that are there that help, but you can also get involved. You may want to become an academic coach. An academic coach helps first semester students. Sometimes it's hard in the beginning to get acclimated to a program. Sometimes our students, it's their first time being in a classroom, even though it's an online classroom, in quite some time. So these are all things that are in the works and ways that you can get involved as well. Events, the same way that we're having a webinar today, we do events and webinars with current students. We like our students put together their own meetups, but we like to bring students together for various events. If we have a new course, if there's a new professor, if there's any type of change in the program, we like to bring students together, inform them about changes, inform them about a new course or a new professor. And this is what ways that we can bring students together. In addition, we have planned events. This past fall, we had our Fall Fest on campus. This was a way to bring all of our current students, whoever wanted to participate, they could come to campus. It was a 3-day event. It was made up of networking. It was made up of professors having various little mini seminars and workshops. And then it was a lot of socializing as well and a lot of fun events as well. And it was really a great 3 days here. And actually, I think everybody went to a football game. So lots of ways that you can connect. And we love that we're able to bring our current students to campus if they're able to get here. And then of course, commencement. We want everybody to come to commencement when it's time to graduate. We had our first in-person commencement last May. We're planning our upcoming one for this May, but it really is a great opportunity to meet all of those students that you might have been conversing with, through various channels, and it's a great way to meet them in person. And I was really amazed at the camaraderie, and it seemed like people knew each other forever. And meanwhile, a lot of times they were just meeting each other for the first time at commencement. So highly recommend that as well. But the main way to connect, we make sure all of our students have access to the Slack workspace. It's a great way to communicate with other students. There's tons of Slack channels. There's Slack channels based on, say, geographic area. There's Slack channels based on courses, all different types of, there's Slack channels for pets if you have pets and you want to talk about it. So lots of different ways to connect with the community. We realize that online programs sometimes can be isolating, and we do our best to make sure that's not the case with our Penn Engineering Online students. We want to make sure they are collaborating and connecting with the rest of the community out there. So like I mentioned, we did on the next slide, we did have lots of events. We have our Slack channel, we had our Fall Fest, our graduation events. These are all things that we really feel strongly about. These are things that we want our students to be involved with, and these are ways that you can stay connected as well. In addition to this, we also have road trips. We have planned road trips to various areas. Last year, we were in Seattle. Associate Dean Liu was in Singapore, and he made sure that he had a group of students that he got together with, and he met with them. It looks like they were out to dinner or out to lunch or something there. But we have another trip planned this summer for the Bay Area. And what we do is we go out, we bring together current students, we bring together alumni, and we bring together some of our corporate partners, and we meet, and it's another way that we can bring everybody together to make sure we have that vibrant community. So we're hoping to do a few more later on in the year as well. And the interesting thing is that, these are sort of planned out meetups and location visits. But what I'm finding out from talking to current students, if they travel, they also reach out on Slack channels to see if other students are in that area, and they put together their own meetups in certain areas. So really highly recommend you get involved with those Slack channels, and you can put together your own meetups or study groups in particular geographic areas as well. It's really important. The next thing I want to talk about is, which is really important. I'm sure many of you have started your application. We do have a deadline coming up on May 2nd, and I cannot believe that that's just about a month away. Time is really flying here. It's going to be April very, very soon, and then the May deadline will be upon us. So let me spend some time talking about the application elements. So first off, there's various elements that you have to work on for your application. Our application is pretty turnkey, pretty easy to complete, but of course you want to put some work into it. So as far as the resume, make sure you have an updated resume. Make sure your resume is highlighting all the things that make you a great student or a great candidate for the program. So take a look at that resume and make sure you're highlighting, what you would need to highlight to show that you are a good applicant. Maybe courses that you've taken. If you're not, Professor Liu talked about the 3 criteria for applying to the program. Perhaps you didn't have a computer science major, but you took some of those computer science courses. You might want to have just a little section to call that out on your resume. Some of our applicants do that as well. So for your personal statement, very important that your personal statement, you answer every question that we ask in the application. So you want to be answering all your questions. And the other advice that I like to give is have somebody else read your personal statement. That's important. Have them read the questions, have them read your answers. Don't you be the only person to read it. Have another pair of eyes on it as well. Now, as far as college transcripts go, we do need official transcripts. Unofficial transcripts are what we need, and we need them for every course and every school you attended. We do not need official transcripts at the point of application. So PDF copies of your transcripts are perfectly fine to upload in the application, but be sure you include every school you attended. So if you started an undergraduate program, say at a community college, and earned some credits there, we will need those community college transcripts or the first college transcripts as well, okay? Regarding letters of recommendation, we only require 2 letters of recommendation, but we always feel, everybody on the admission teams always advises to seek 3. And the reason why is the letters of recommendation are the only element that's out of your control. It is up to the recommender to get that element in on time. And recommendations do have to be in by deadline. So all letters of recommendation will have to be in by May 2nd. So since it's out of your control, it's better to have the safety net. And if you have 3 good recommenders, then I would advise to seek those 3 instead of 2. This way it gives you a little bit of a safety net. As far as the recommenders to choose, the title of the recommender is not that important. It's how well the recommender knows you. And it should be a supervisor, a manager, somebody that's above you on the chain that oversees your work, knows the type of projects you're working on, knows the type of worker that you are. Or if you're coming from a program, from an undergrad program or a graduate program, it certainly can be an academic recommendation. So you want to choose professors that know you well. Perhaps you've done some work for them, or you were a TA for them, or whatever the case may be, but choose professors that know you well if you're seeking academic recommendations. The one thing that I want to stress is everyone seems to think that we require academic recommendations. We do not. It can be an academic recommendation, or it could be a professional recommendation. Certainly, if you've been out of school for quite some time, we wouldn't expect you to go back and seek a professor's recommendation. That won't really, make all that much sense. But again, it should be a manager, a supervisor, somebody that's overseeing your work. Or again, if you are still in a program or recently graduated, it certainly could be an academic recommendation. As far as the GRE or the GMAT, we do not require them for the application. Some applicants will use the GRE if they're trying to show say quantitative ability, if maybe some math courses, maybe they had lower grades in them for some reason, they certainly could take the GRE. It could help with the application if needed, but it's certainly not required. We don't expect a GRE. The application is not looked upon any differently if you don't have one, but it certainly can be a tool if it's needed. So it's there for you if you feel you need it. And the TOEFL will only apply and be needed for our international students, or I should say, for our students who are not US citizens or US permanent residents. So if you're not a US citizen or a US permanent resident, the TOEFL is required. However, the TOEFL can be waived if you went to a university or a college where the program was completely taught in English. So if you have a degree from a university or college, the program was taught in English, then the TOEFL requirement can be waived. So, and there is a $90 application fee. So prior to submitting, you would submit your application fee, and then you can go on and submit your application. Now, once your application is submitted, we have an incredible, a really great applicant portal. You can see your checklist. So if you're waiting for your recommenders to submit the letters of recommendation, you can go on that checklist, and right there on the checklist, you can see when recommenders submit their letters. So if it's getting close to that deadline, that May 2nd deadline, and you don't see those letters submitted, you can contact your recommenders and remind them, and please ask them to get them in by deadline. You can see that all on your applicant portal through the checklist. And there are the dates that you can see. May 2nd is our final application deadline for the fall 23 time frame. And then we will return decisions. All decisions will be returned on June 15th. Deposits are due on July 14th. And then our onboarding course, which gives you lots of great information to prepare you for the program, would begin July 17th. And our classes will be starting at the end of August. So that kind of gives you the nuts and bolts of the application process and the elements that you need and the dates and deadlines. Now, you might think, there might be some people on here that after Associate Dean Liu has gone over the criteria for applying and the curriculum and whatnot, they might feel, oh, maybe I'm not quite ready. Maybe I don't have exactly what I need to apply to the MSE-DS program, but I really love the program. What should I do? You might want to look at our MCIT online program. You might want to start there. So our MCIT program is for applicants that really don't have computer science, or maybe they have minimal computer science background. So this is a great program to start with. So you might want to start with that program and take a look at that program. That could be an avenue for you. The great news is we have a dual degree program between MCIT and MSE-DS Online. So you could start with MCIT. When you're in your last semester, you can apply to the MSE-DS Online program. And then if accepted, 4 courses from MCIT Online would also count for MSE-DS Online. So 4 courses would transfer from MCIT to MSE-DS Online, and that would leave you only 6 courses to complete the MSE-DS Online program. So that's our dual degree program. If you thought you had what it took, had the necessary requirements to apply to the MSE-DS Online program, but you really don't, and you think you need to start, you don't have any computer science, and you weren't a math major or a quantitative major or anything along those lines, then start with the MCIT program, and then you could work on getting the dual degree and applying to the dual degree program and going that route. So that's a great option and a great opportunity as well. So I think we are at the point now to open it up to questions. So let's see what we have going on here. I did see a bunch of them coming through. Just give me a minute to check the screen and see what's going on here. Okay. So here are a few questions. The first one says, are there avenues to explore projects, internships in collaboration with other Penn departments?
Sure, let me take that question. So first of all, our computer science department is part of the engineering school, and there's a lot of cross collaboration across different departments. And so I know there was a question about astronomy. So the University of Pennsylvania astronomy is part of physics, so it's physics and astronomy. We actually have a number of faculty in our engineering school which has appointments outside of engineering, right? Some of them could be in material science and chemistry. I know there are folks in biology and computer science and so on. Now, so why do I mention this? It turns out towards the end of MSE-DS, there's the option of doing a data science practicum, which is basically a chance for you to apply everything that you have learned in practical scenarios. And for that, we will be soliciting research projects from faculty members across campus in the area of data science. And at that time, there could be such opportunities open. And I'm glad you talk about it, because our engineering school we do not believe that data science should be done in a silo, right? We have, for example, computational folks, even in material science and chemical engineering. We have hired faculty outside of computer science. They sit in another department, but if you don't look carefully, you might mistake them for a data scientist as well, right? And the reason is very simple, right? Today, any field that touches upon sustainability, materials, astronomy, as you mentioned, it all boils down to being able to make sense of large amounts of data. And so a university like Penn is really at the center of a lot of this work.
Excellent. Okay. Let's see. Another question that we have, it says, what career can a graduate from MSE-DS Online hope to expect?
I think that there are different career paths, and each one of them will require you to choose a different set of classes. And so when you come to Penn, I hope we're lucky enough to get you to become one of our students. You should talk to our academic advisors and also to faculty members as well to guide you. And so let me give you a couple of potential career paths. You may decide you would like to focus on the data and the data forecasting and data analysis side of things. And there are wonderful jobs out there, right? And here it could be in quantitative finance. It can also be in credit scoring, where you're trying to understand someone's credit worthiness. It could even be in ed tech, right? In education, where more and more increasingly data is used to make recommendations and to figure out, learners' progress and so on. Now, any field that requires you to make sense of data through algorithmic and mathematical principles, I think you can choose a set of classes in our program that will help you fulfill your goal. Now, as a second category of students, you may be interested to become a software engineer, but one that focuses more on data infrastructure. And let me give you an example. One of the key innovations that came out in the last few years is a technology called Spark, right? And Spark came out of a company called Databricks. I'm sure some of you have heard about that. It's one of the famous unicorn companies. And actually, I'm really proud of that company because it's founded by my PhD advisor. But that aside, Spark is a platform used to do a high performance data analytics at scale, right? Across a large cluster of machines. So the user could be a data scientist who may not necessarily be a distributed systems or computer software engineer expert, but the people who build Spark needs to be both good in data science and data engineering and infrastructure building. So if you're interested in that type of career, going to companies like Meta and Google or Bing, Azure, to work on this kind of next generation data infrastructure tools, then certainly there's a set of classes for you. And for this second area, I think there has never been a better time because we are in this interesting evolution now where search engines are becoming smarter and smarter through the use of AI technology. So it's definitely a very viable area. Last but not least, and the list could go on, I could spend a whole day talking about it. There's a lot of innovations in IoT, Internet of Things, in self-driving cars, self-driving vehicles, and so on. And a lot of that are actually AI, machine learning driven software that works in a tight control loop. and certainly a lot of interest in that area, eventually will touch upon adjacent engineering discipline. For example, you may want to make data-driven decisions that can help you make real-time decisions on your power grid and your water infrastructure and so on. And I think this is an emerging, growing area, especially with climate and sustainability kind of a focus, that if you equip yourself with the right skills through MSE-DS, you could future-proof your career for the next 30, 40 years.
Yeah, absolutely. I think the sheer fact that you said you could talk about this forever shows that there's lots of opportunities in this area for sure. The other thing I just wanted to piggyback onto that is that even in addition to the student advisors that you have, we have a great career services department too, and Emily Perry heads that up as the associate director of that department, and she helps our current students if there's a career change to be made or changing into a different company or field or industry or whatever the case may be. She can help with that and does have contacts and can give lots of advice on how to do that. So she works with all of our current students. Her and her team will work with current students to help them in that area. So that is an excellent resource as well that you can take advantage of for sure. Okay, let's see another question here. So it says, how does your program compare to other top data science programs? They mentioned Stanford's and Carnegie Mellon's. And what are some of the value propositions compared to those programs other than having the online offering?
Sure. I think there's a number of different data science online programs around the country and around the world. And when you explore these programs, you have to first figure out where these programs are offered. Some of these programs are offered as part of the business school, in which case they would be much more focused on business data analytics. And those programs would not train you very well for some of the career paths that I mentioned previously, except for maybe in quantitative finance. Another set of programs could emerge from College of Arts and Science. So you got to do your due diligence to figure out who are the faculty teaching. Are they in a computer science department that situates within an arts and science college? Or are they part of the business school? Or are they part of the engineering school? Right? I would say our biggest value proposition is that we are part of the engineering school. We're fundamentally engineers. I consider myself a computer engineer, somebody who likes to write software, but I also know how to tinker with hardware and know how to, wire together machines in the data center. And it's really that engineering DNA that I think separates us from the other programs. Many of the faculty members that I mentioned earlier, we are folks that would build software, build infrastructure, and also we are all very research active. You can see how quickly the field in computer science changes. I was just remarking to another faculty who was listed earlier on how the field of machine learning and AI has changed over the last few years. In fact, 5 years is eternity in this area. And 2 years even, you could go out of date really quickly. And so why does it matter? It matters because a lot of our faculty are at the forefront of technology. We're still doing cutting edge research. We're getting funding from NIH, from Department of Defense, National Science Foundation. We all still attend regularly top conferences. We have a lot of connections with industry, which means you're learning today and tomorrow's technology. And I think that's going to be one of the key factor differentiating. So to summarize, 2 key differentiation: engineering DNA and also faculty at the forefront and the cutting edge of technology.
Excellent. Thank you so much. Next question. Would you mind sharing how does the program balance theoretical and practical aspects of data science?
Sure. Now, as in anything, I would always recommend students to diversify and have kind of a good mix of mathematical and also practical aspects of data science. That said, depending on your personal interest, you could steer yourself one way or the other. For example, if you find yourself very much in love with the statistical side of data science, and that's what you would like to focus on in your career, you could design a curriculum for yourself, which maybe would include 7 classes that are more mathematical in nature and 3 classes that are more systems and practical in nature. Example of mathematical classes, for example, would include the linear algebra class taught by Professor John Gallier and Professor Jocelyn. We have the ESE classes that I mentioned earlier, which are more in the area of statistics in data science and in the area of deep learning. And those classes, I wouldn't say like the entire class, but elements of those classes could get very mathematical, right? Today, if you walk into a data science class taught by a statistics or electrical engineering faculty member, if you walk into their class at Penn, you're going to see equations from the left corner of the chalkboard to the right bottom corner, right? However, that will give you one aspect of data science. There's another aspect which is more on the practical side of things. How do you build large software, right? So in my class, for example, students have to learn how to install a Docker container to understand how virtual machines work. And as their final project, they have to build a large scale key value store and then build like a Google mini search engine kind of thing. That's actually also data science, but that's data science at scale. And there's going to be a lot of opportunities for you to tailor your training towards more group-based projects that will cover the practical aspects. But one thing that I want to mention is we are not a vocational training kind of place. So we would not, for example, spend a ton of time telling you how to use the Tableau tool, right? It's part of something that we hope you would pick up by yourself over time. And so a lot of our practical, so-called practical training would really be more on the fundamental computer science training. I do want to mention a interesting new class we are launching on the Google Cloud platform, which is a very hands-on practical class, which students will learn how to use cloud technologies. And even though the examples are based on the Google infrastructure, they could very well apply to Amazon and Microsoft and other infrastructures as well.
Okay, great. Next question. How would you describe the difference between a software-focused class in this program and a boot camp class?
So we have, for example, through our collaborations with LPS, run a data science bootcamp, which I'm proud of our collaborations with our College of Arts and Sciences. And I would say that there are some key differences. In a typical bootcamp, you are learning vocational skills, right? How to use this data visualization tool, how to use certain advanced features in Excel, how to write Python code that will call all these PyTorch and all these machine learning API calls. And so you could use that to, complete some data analytics task. And those boot camps tends to be a little bit short, which means they'll focus a lot on the how to use certain technologies today, but not focus on the long-term why, right? Which is, I think, the more important part of it. And let me give you a concrete example. Some of you may have used databases in the past. If you go to a boot camp, they will train you on how to write SQL in 10,000 ways, right? Or, write SQL query this way, write it that way, and maybe build a nice front end and connect it all together. But in our classes here, we would, for example, teach you how the SQL query would actually be implemented in the databases itself. So you learn more of the underlying principles. And those underlying principles are very important. For example, today, if you write an SQL query and it runs really slowly, right? Instead of taking 3 seconds to run, it takes an hour and you're still not getting the results. That is actually both a systems and algorithms challenge that if you give to somebody who has gone through a boot camp, they are less equipped to figure out why that's happening than somebody who has gone through a more rigorous computer science training.
Okay, very good. Well, believe it or not, we are quickly running out of time. This went so fast. Thank you so much. What I wanted to do is just before we part today is just wanted to go through next steps for everyone out there in case you do have more questions, and you know, what do you do now and to try to finish up your application, or if you're just starting your application. So after the webinar today, obviously, like I mentioned, it is recorded. So you are welcome to go back and watch it as many times as you want. And again, look out for other webinar recordings as well. But I advise you to check out our FAQ database on our website. Lots and lots of questions in that database. Type in your question and see what comes up. But we really do have a pretty extensive FAQ database. So definitely check that out. We also have our admissions team has office hours. We have office hours every day of the week. And even towards the end of the cycle, getting close to deadline, we have Saturday morning hours as well. So if you would like to meet with somebody on the admissions team because you have questions about your application or questions about which program is right for you, certainly sign up for office hours. They're in 15-minute slots. We're happy to meet with you, and that's a great way to get your questions answered. You can also email us. Our email address is on the screen there. We do our very best to answer all emails within 24 hours. So if you email us, we are typically getting back to you within 24 hours. The other thing I wanted to point out, it should be on here, and I probably forgot to put it on. We have lots of coffee chats. We have several coffee chats coming up the month of April. So what you want to do is go to our website at the very top, go to events. It'll list all of the events that we have for the month of April. We have about 5, 6 coffee chats coming up. Those are a great vehicle for you to have your questions answered. It's a very informal session. You can ask your questions. And what I like about it is you can actually hear what other applicants, other potential students are asking. They might be asking questions that you didn't think of. You can hear what they're doing. I think it's also a great vehicle. Even if you don't want to ask any questions, if you just want to listen to others' questions, it's a great resource and a great vehicle to learn our programs and learn the application process. So definitely go to events. We also have another webinar coming up on April 12th. Emily Perry, again, I mentioned her from our Career Services Department. She will be on with an alumni panel. So we are going to have graduates from Penn Engineering Online. Our alumni will be on there talking about what they're doing now. Many of them did not come from a tech background. I think we have somebody from finance, somebody that's a teacher, and I forget the third one, but what they did and how they how they switched into different careers and what their journey looked like. So you may want to attend that webinar as well to hear what some of our alumni are saying about Penn Engineering Online. So lots of ways to get in touch with us. Again, if you have any questions, please reach out. We are happy to help you. We thank you for joining us today. Associate Dean Liu, thank you so much. As always, you were great and we appreciate it. I love listening to you. So thank you so much. Everyone have a wonderful rest of your day, evening, morning, and we'll see you soon. Thanks so much. Bye-bye.